Hello all. So our next lab, at least this week, is solid waste prevention. So before we get into this lab, one thing I want to mention is that you should check out the last slide of this activity before you begin anything else, because this involves kind of a week-long process of gathering household waste, and I'll talk more about that towards the end of this activity. Okay. So the focus of this lab is municipal solid waste, which is abbreviated as MSW, which we'll see later on throughout this activity. It's the name given to any ordinary office or household trash, that which we generally dispose of through usual garbage collection services, offered or contracted for by municipalities, in this case towns or cities. So just basically what we throw away on a regular basis, most of which we throw away, which goes into landfills or into incinerators eventually. Now our trash is, like it says, made up of the things we commonly use and then throw away. And these can include things like packaging, food scraps, grass clippings, old furniture like sofas, computers, tires, even refrigerators. To be municipal, however, it means it cannot include industrial waste, hazardous waste, or even construction waste. So again, like I said, we're talking about what we commonly throw away on a daily basis in the home or maybe at work. So how we deal with waste in the United States, there's kind of a tiered system that we use. In this case, from what we most prefer to what we least prefer. And as you can see here, our general preference is to reduce waste at the source. This is generally our policy of dealing with pollution in the first place. So for example, if we're trying to deal with plastic waste, one thing we've done is we've reduced how much plastic we produce and how much we put into our products that we use every day. So for example, 2 decades ago, plastic bottles used a lot more plastic than they do today. And so initially, by reducing it at the source, at the assembly line, means less plastic winds up eventually in landfills. So that's our general preferred method, is source reduction. Whatever we cannot reduce, we reuse. Right? So with reuse, we basically just take the product and we use it again for its intended purpose. So if you're going to empty out a bottle, you might take the bottle and refill it again at a later date. So like a water bottle, for example. That's just reuse. Recycling would be taking the product and then turning it into a new product. So if you were to take a plastic bottle and ship it back to the manufacturer, they might melt it back down, turn it into new plastic, which could eventually be used to make new bottles. Or the bottle could be turned into something like another product. So for example, commonly PET plastic is turned into clothing, for example. We also have resource recovery, and so that's where you take the product and then you basically, for example, we commonly do this with things like batteries. They contain heavy metals in them, but what you do with them is you take the valuable materials out of the product, and then you, like for example, they have cadmium and nickel in batteries, and you take those resources and you recover them and you use them for something else, maybe to make new electronics, for example. We also have incineration. Incineration is where you actually burn the trash, and that actually reduces the volume of waste by quite a lot, because you're actually reducing it to ashes. However, the problem with this is that it also produces air pollution, so it is not necessarily ideal. And the most widely used but least preferred method of dealing with waste in the United States is to landfill it, and that's basically where you take the waste, dump trucks ship it to a waste disposal site where it is put into these basically these pits in the ground, and then they're filled in with basically sand, soil, or dirt, which is why we call it landfilling. So they're basically just covered up, and the volume of the waste still remains. It's just out of sight, and of course that's not ideal because the waste still remains underground for quite a long period of time. So as you're going to see as we kind of progress through this little PowerPoint here, I've got several images that I kind of want you to analyze. Now, all of these images are taken from between 1960 to 2006, so I know they're not the most up-to-date, but for consistency's sake, I use them because they're all basically from the same data set from 2006, and the trends haven't changed remarkably in that time. So looking at this first image is municipal solid waste generation rates. One of them is the total produced in the United States, and this is in millions of tons. And as you can see here, as of 2006, we are at 251.3 million tons of municipal solid waste generated in the United States, up from 88.1 in 1960. So it's more than tripled in the United States. We also have the amount of waste generated per capita, and this is in pounds per person, and that's per day. Okay, so that's 4.6 pounds of trash generated per person per day in the United States as of 2006. And as you can kind of see, it's kind of leveled off in recent years. Here we can also see recycling rates in the United States. And here's a positive trend, because what we see here is recycling rates in the U.S. and per person in general have increased. So here you see the total municipal waste recycling in the United States. It shot up from 6.4%, 5.6 million tons in the United States, all the way up to 81.8 million tons in the United States. In addition, recycling rates overall have increased from 6.4% to 32.5% since 2006. And it's only kind of risen slightly higher than that recently. So 30% of our waste is recycled in the United States. Here we can also see recycling rates of selected materials in the United States. And I want you to look at this diagram and kind of see, well, which items are the most widely recycled and which are not. And you'll commonly see that plastic drink bottles and milk and water bottles have about a 30% recycling rate, and that's fairly low. Also the same thing for glass containers. Often these never make it to a recycler. The main reason why is because when we drink soft drinks or water, we kind of are on the go, and so we often don't throw them away in recycling containers like we should. They often are just kind of thrown by the wayside, and they never make it to a recycling center. Glass containers frequently are broken or chipped, and so they also may never make it to a recycling center. On the other hand, you actually see that some items have a fairly characteristically high recycling rate. Why is that? Now, figure 4, which you can see here, shows the fate of all the United States municipal solid waste. So where does it go? Well, you'll see here that discarded is the amount put into landfills. Recovery is the amount that is recycled. And combustion is the waste that is incinerated. And some of that incinerated waste actually generates energy. They actually use it as a fuel. So in this case, well, which primary means of disposal? Okay, how do we manage most of our waste in the United States? Kind of analyze this pie graph that you see here. So what is so great about recycling? Well, like it says, making a soda can from recycled aluminum uses less energy, 95% less, and it reduces mining impacts such as pollution because less aluminum has to be mined and smelted. You'll see this in the textbook, but as it mentions, aluminum ore actually comes from or aluminum metal comes from an ore called bauxite. And so you actually have to mine this bauxite and extract a small amount of aluminum to actually produce new cans. In this case, because it comes from the ground, aluminum is a non-renewable resource, so extracting it from that ore means wasted energy. And in fact, as it mentions here, 20 ingots of aluminum can be recycled for the same energy it takes to produce just one to process that bauxite ore that I talked about earlier. Of course, the benefits of recycling depend on what material is being mined or extracted to make a profit. The figure 6 shows the waste as classified by its original use, not composition. Okay, so in this diagram, like it says here, this is the total municipal solid waste generated by material, accounting for the 251 million tons in the United States. Now, one thing I want to mention here is that people often don't realize this, that recycling, as I mentioned earlier, is basically taking a product and breaking it back down and using it to make a new material. Composting is actually a type of recycling. That's where you take organic materials like food waste and you actually allow them to rot, which is a process of breaking down and then turning them into a soil amendment, a fertilizer. And so technically composting, recycling vegetables or even yard waste is a type of recycling. So what is recyclable? Well, I want you to use this as a reference in the next activity that we have here, but you can see here some commonly recyclable items and others that are not quite so recyclable. So one common misconception is, especially packaging, is what type of packaging, especially if it relates to food, is recyclable. Now, I did want to mention just briefly here that some packing boxes for food are recyclable, but not if they contained food, and in this case, they're not stained by food. For example, pizza boxes are made of cardboard, and cardboard is recyclable. As it mentions here, packing boxes can be recyclable. The problem is that if it has soiled food on it, like pizza grease or cheese, for example, it cannot be recycled. Generally, that's not the case. In addition, if the carton is waxed, okay, waxed cardboard or milk cartons, those also cannot be recycled. In addition, anything that contains chemicals, like paint cans or aerosol cans, or for example, if we look at, let's see here, where's the other one at here? Yeah, or what was that? Light bulbs. Light bulbs are commonly not recyclable. Now in class, we would sort through a bag of household trash. That is, it would not be actual trash, but a bag that was put together to simulate household waste, containing everything but food waste to make it sanitary. We would hand sort with gloves the waste from the trash and individually identify the items that would be recyclable and those that were not recyclable, using the same diagram previously. Then we can determine how contaminated the trash was. Contamination would refer to which items did not belong in the trash, i.e. if the item was recyclable. It should not be in household trash. So what items on the right can we see that are recyclable and which are not? Looking at this image on the right, we can see glass bottles. Okay, those are certainly recyclable. They can be melted and recast into new bottles. We have plastic drink bottles, which again can also be melted down and recast into new bottles. We have jars, also made of glass. And we have newspaper, which can be shredded and turned into insulation, for example. We also have some items that are not recyclable. So we have the jar lid, for example. We have styrofoam containers, which you can see here. So here's two. And we have plastic food wrappers. Those are a type of plastic that is not recyclable. So going back, so yes, this is trash contaminated with items that could be recycled. So our task is to perform a waste audit to determine the percentage of contamination. We're going to identify all the recyclables and divide by the total number of items in the trash bag or trash can. What you do is you sort through the trash at home and find in one bag of garbage. This is just an example. So let's say we find 2 tin cans, 6 aluminum cans, 1 styrofoam egg carton, 1 cereal box, 1 light bulb, 5 sheets of computer paper, 1 newspaper, 2 AA batteries, and 3 plastic water bottles. Okay. So out of this, we have a total of 22 items in this bag of garbage. Referring to slide 9, the recyclables versus non-recyclables, there are 18 items which are considered non-recyclable. Okay. Excuse me, that should be 18 items which are listed as recyclable. Okay, sorry about that. In blue, those are listed as recyclable. Okay. So if 18 of these items, as I've totaled them up here, are listed as recyclable, and I'm only including the batteries as non-recyclable because in most cases, even though the sheet says otherwise, they are not. So in this particular case, I'm categorizing them as non-recyclable. So 18 items are listed as recyclable. So just kind of scratch that there, are recyclable. The percent contamination would therefore be 18 out of 22. In this case, 18 out of 22 times 100 would be 81.8%. Therefore, in this trash, which is bound for the landfill, it is contaminated with 81.8% of recyclable items. That's kind of nuts when you think about it, because that means the vast majority of that trash could have been recycled. Think about what kind of impact that would have on you at home if you were to reduce your waste volume of your trash by that much, 81.8%, just by sending most of this to the recycling center. Now for 1 week, what I want you to do is to set aside a small garbage bag, and I'm talking about these little garbage bags that are about 2.6 gallons, or you could use a paper grocery bag if you have one of those, but basically whatever you have on hand to kind of perform this activity. But during the week, place household trash into this garbage bag. Do not place food waste in this bag to avoid spoilage or bacteria. The idea is that you're going to have to sort through this trash, and so you do not want anything that could be rotting or could potentially cause disease. Now, of course, you can use gloves, and I encourage you to during this activity. I think most of us these days have them because of the situation that we're in. But when the bag is full by the end of the week, whichever comes first, empty the bag and perform a waste audit on the contents. So what you're going to do is divide the contents of the bag into recyclables and non-recyclables. Use the space provided at the end of the D2L quiz to list the contents and provide a percentage contamination. So this is question number 6, and it's worth 5 points. on your activity. Now I've uploaded a sheet which has this information on it right here onto D2L, so you can access that if you want to print that off before you get started. But of course you can also go back to this slide here if you need to. All right, so as I said, I would start this at the beginning of the week if you can. All right, so start this at the beginning of the week, and then by the end of the week you should have some trash to analyze. All right, so that's it for this week's lab. Please contact me if you have any questions.